Really quick, our day one was, you can keep me honest, December 30th or I think December 30th of 2021. That is when the deal was finalized and kind of that day one stand-up of Solidigm as a wholly owned subsidiary of SK Hynix. And so we were formed by Intel selling its NAND SSD business. As everybody knows, Intel is still running Optane, getting out of Optane as they deplete that inventory. But we are the combination of Intel's former NAND SSD business and SK Hynix SSDs. So that is us. We like to think, and hopefully we're going to show you as we walk through the material here, that we bring some pretty cool technologies spanning QLC, TLC, and for those delegates who hopefully looked at the last storage field day, we use this as a pretty exciting opportunity to launch our first SLC device. And so we'll kind of talk about that whole stack as we go through the presentation. So that's kind of who we are. We've got a global presence. We are headquartered kind of a combination of the Bay Area in R&D up in Rancho Cordova outside of the Sacramento area. I think about 2,000 employees worldwide, offices, manufacturing, distribution facilities worldwide. So what we bring to kind of the storage industry is all of the kind of the innovation and the capabilities and the products is built on kind of a combined 50 years, five plus decades of combined storage innovation. So that's kind of what we're showing you here with our innovation histogram, I guess, if that's what we want to call it. When I did the research, when I was first built this slide, I did not realize, honestly, that Intel had a NOR-based flash device in 1988, a prototype. So that's when it all started. I had no idea. Fast forward to kind of more recent and maybe associating those with kind of the theme of today. You can see launching of the industry's first QLC drives, building out that QLC portfolio, stacking even higher layers onto the 4-bit per cell technology, and really kind of expanding that hyper-dense portfolio, which again, we really think is pretty primed to solve top edge storage challenges. Oh, also worth mentioning, because we think that this is, and Janice will go into some details here, with our legacy at Intel, we also have roots in basically inventing the EDSFF drives, and given kind of the efficiency and operational efficiency benefits of EDSFF drives, we see that as a strong value play for edge as well. Okay, so really quick, our data center strategy. I think I've kind of touched on this. Best-in-class solutions for all workloads. You'll see a bit more of that play out as we go through the portfolio of SLC, TLC, QLC. Lead in storage density, really that is primarily driven by QLC, but also, as you saw in Storage Field Day, where we launched SLC and then talked about this rate-shaping software called CSOL. You put that in a solution with QLC, and now all of a sudden you've got the opportunity to get all the benefits of QLC into many workloads, even write-intensive workloads. So kind of bit beyond that big swath of read-intensive workloads that QLC is really primarily targeted at. Okay. And then, kind of a visual of our form factor portfolio. Okay, so let's kind of get into more of the meat of the presentation. So, next couple slides this is our perspective on kind of what's going on in terms of how the storage landscape is shaping from the core to the edge, and, kind of Solidigm's perspective on kind of how this presents maybe unique locality constraints and storage challenges at the edge. So what we're showing you here, and this is by no means, disclaimer there, this graph portrays general direction, is not an exact model. This is just kind of, high level, as everyone knows, there's a lot of data being stored. Most of it today is being stored in the core. Most of that core data center storage is on HDDs. In fact, various studies suggest that up to 90% of core data center storage is still on HDDs. So we think that's a huge opportunity for QLC moving forward. And then certainly there is, an increasing, you'll see this on the next slide, an increasing amount of storage being done at the edge. And as you get to the edge, and we'll talk about this in some more detail, the edge presents some pretty, I wouldn't say unique, because I think storage challenges are fairly common, but some more intense challenges, more acute storage challenges when you talk about some of those locality constraints in terms of size, available power, weight. When you talk about an edge server that maybe you want to put in a kind of a different location or have a more portable edge device. So we'll talk about those locality constraints in some more detail. Now, what we see moving forward, and again, not an exact model by any means, but we see for reasons of cost, it costs a lot to move data up, back and forth on the network. There's some estimates that say moving data costs 3 to 4x more than storing data for reasons of privacy, security, and maybe most important, responsiveness, latency, user experience. We see more and more data being stored at the edge. And so we're seeing not only obviously a growth in data fueled by modern workloads and technologies like AI and 5G, not only is that creating more data, but again, given the reasons that we just talked about, we see more of that data being stored at the edge. Now, what we're showing you here is kind of an eye chart. We've got 4 embedded charts, and this is where I wish I had the laser pointer, but that's okay. We'll walk through this. So we're showing you some IDC data here. And if you look at the left of the slide, what we're showing you there is, kind of that core to edge infrastructure server to endpoint server and endpoint devices. The left graph is kind of where data is being stored. Now you can see that the left graph isn't, the numbers might look a little bit different than, kind of that image that we showed you on the last couple slides. But what we thought was interesting about this IDC study is then they've got broken out as you move from the bottom center to the far right to the top center. Kind of where that storage is going as you go from core to mid-tier to edge. And a couple interesting observations here. One, you can see that there's a massive HDD displacement opportunity. HDDs in the 3 breakout charts are depicted in green. 2, you can see that storage is growing fastest at the edge. You can see the CAGR numbers in the bottom center at core. Then you see the CAGR numbers in the center right and top center, growing 50% is the SSD compound annual growth rate. And that's kind of what I'm pointing out in the last bullet is huge growth opportunity projected by industry analysts for SSDs at the edge, kind of mid-tier or edge infrastructure servers, edge kind of endpoint servers, and obviously edge devices.
Do you know what the driving factor behind that was in terms of why is edge SSD going to grow faster than stuff at the core?
Good question. And we're going to talk about that, but locality constraints, I think I was going to say one word, is the 2-word response. Locality constraints in terms of SSDs have higher reliability. Reliability is a huge concern at the edge. You think about how kind of distributed these are and the cost around that. Operational efficiency. SSDs can lend themselves, particularly when on an EDSFF, hardest thing to say. When on that form factor, there's huge operational efficiency advantages. Size, weight, capacity scaling, performance scaling. As the number of ingest devices at the edge grows, the need to have that endpoint, kind of in parallel scale both performance and capacity. That is really well aligned with SSD
And
capabilities.
what about like environmental kind of factors, and durability wise?
Exactly. Yeah, you're talking about like military standards, vibration, shock, a little bit of an extended thermal. Matter of fact, I think the demo that we're going to be showing you, that our friends from Storage Review are going to be showing, is a cheetah RAID implementation. And I don't know this specific device, but cheetah RAID literally makes these kind of small servers that go in backpacks for defense usage. They make smaller ones that go on in transportation on ships. So those are, yeah, a couple good examples there. Okay, so I wanted to actually, I'm going to back this up because I took a long time to do this clever build, so we're going to use it. Okay, so I wanted to kind of show you transportation, a smart automobile, connected car is kind of an example that's illustrative of kind of this edge data growth and increasing storage need. So yeah, so let's look at it. So we've got this simple construct here of core data center, edge infrastructure servers, endpoint. Obviously, in this case, the endpoint is literally you've got increasingly little servers in cars. It's just amazing. And you can see connected car, looking at this example, is expected to, undergo massive growth through the rest of this decade. And as we look at the far edge, in terms of the car, you're seeing sensors nearly double every 5 years or so. I think Tamid's going to talk about this a little bit more. You can see the massive data ingest, running up to nearly 20 terabytes per hour. I think that is, and not only it's cool, not only can you approach that, you can approach that in smart agriculture as well. John Deere's See and Spray technology. It's like 40 high definition cameras, 2 GPUs on board, and literally just doing this precise micro spraying for fertilizer, insecticide, et cetera. So there's a massive amount of data ingest here, and it's going to get even more as more connections are made. We're talking about the car example. You're talking about smart cities, smart roads, weather, entertainment. Even more data being ingested. And what we're showing you there in the bottom right is you kind of take the most advanced production vehicles, what the typical storage is. You take an advanced test vehicle. So these are the vehicles you see driving around and just gathering massive amounts of data. And we actually have design wins in these test vehicles. Then they're going back to the service bay, downloading the data. And so right now, your most advanced test vehicles have about 30 terabytes of storage, which presents a limitation to them in terms of the number of hours they can be driving on the road and gathering information. So then we kind of look back upstream and we talk about the core data center and edge infrastructure. And now we're talking about where the model training is going on. And these models are growing, 10x every 2 years, conservatively. And there's more and more data being fed upstream back into these models. In a lot of autonomous cars today, connected cars, I might not be speaking the right lingo, but it's in some cases just kind of event-driven data is pushed back upstream for model training. Tesla now is taking the full driving log and moving that upstream. And then you can see, I speak there about vehicle data uploaded. And so right now, today, we've just kind of chosen a representative core data center server based on HDDs, typical edge server, and a lot of those are still on HDDs, probably edge infrastructure moving a bit more to SSDs right now. But again, what this is presenting is with this massive amount of ingest and the need for faster and better decisions at the edge, it's really straining, we believe, kind of this storage ecosystem from core to edge, but straining it even more when we get to the edge. Okay, so we talked about you were asking about about kind of these edge challenges. So just kind of quickly walking through, I think I've got like 4 or 5 categories of storage challenges here. So how are we doing on time? Okay, we're good. So when we talk about size and weight, obviously everybody knows, when you're in a core data center, you've got an infrastructure that's purpose-built, purpose-built in terms of the size and the weight and cooling and serviceability. And so, size and weight challenges, maybe not so much. But I should mention, we are seeing more and more data centers going vertical. Especially in when you kind of get closer to cities, areas where real estate is more expensive. So size and weight is beginning to become somewhat of a factor in the core, but it becomes even more so, again, when you move out to the edge. You look at I think Open 19 is an industry consortium that is trying to do an OCP-like thing for edge servers, and they have size and weight kind of reference architectures for edge infrastructure servers. And then when you go all the way out to the endpoint, obviously now we've got constrained by the actual physical device size. Power, you've got your typical core data center, 12 kilowatts. I mentioned that Open 19 server. 400 watts is in their reference architecture. I think it's 1U high, half a U wide. You can look it up, Open 19, if you're not familiar with it. And then obviously when you get out to the edge, restricted by power, restricted by common, much lower, much more restrictive power requirements.
I've got a question real quick.
Yeah.
So what's the difference? How do y'all see the difference between edge infrastructure and an endpoint? So can the endpoint actually have all the infrastructure it needs to interact with?
It could be. In this, good question, this varies so much by
Use case.
kind of usage and industry you're talking about. Literally, since we were talking about the automotive one, an edge infrastructure server would be on a utility pole somewhere, and the actual endpoint server would be in the car. I think another good example is content delivery networks. Content delivery networks have a lot of regional data centers and even increasingly kind of local data centers, but then you've got your endpoint device in your home. But good question, it varies so much by industry and usage.
Gotcha.
Serviceability is a lot more challenging at the edge. Obviously, core data center, it is right there, right? You've got, I don't know, a handful of core data center. You get into edge infrastructure, you got maybe hundreds of these locations. You get out into the endpoint device, and now you're talking thousands. So serviceability becomes a problem by numbers and a problem of location because they're far flung. Operational efficiency, kind of same as serviceability, but in this case, in a core data center, you've got your service technicians walking down a hall. Procedures are very well defined. Do this. It's just very structured, very regimented, and the result much more efficient. Again, you get out to the edge. Now, as we were talking about earlier, you've got situations where you're subject to ambient conditions, harsher conditions. Operational efficiency becomes more of a challenge, and I think this is our last one. Uptime and reliability, as everyone knows right now, I should stand on the X, keep wandering around here. As everyone knows, kind of the warranty in storage for a core data center is about 5 years. We believe, and we're starting to hear from customers that especially when when you get out to the edge, that there's a desire to get to a longer usable life, maybe up to 7 years-ish, because now this is sounding somewhat redundant, but you're in a situation where these things are more costly to deploy, more costly to maintain. So seeking maybe something longer than a 5-year serviceable life, 5-year usable life. Okay. Was that helpful at all, just in terms of kind of setting the stage on edge challenges as compared to core data center?
So,
Yeah,
question briefly, if I
sure.
could. So, I liked your example of the John Deere farm tractor.
And I grew up a farmer.
Right.
I grew up on a farm. I drove John Deere, so I like that example too.
Right. But I mean, these tractors are, some of them, $500,000.
Oh yeah.
That you're talking about, and the ability to deploy things, right in the field and make sure the crops that need watering get it, and vice versa. Are there different challenges, or is it almost an overstatement to say mobile platforms like a tractor, a vehicle, have completely different challenges for things like maybe a solar panel farm, or a collection of wind turbines at sea? I imagine there's other challenges there too, right?
Oh, absolutely. I think it's kind of a similar answer to, when we talked about usages. It varies by usage, and I guess I would characterize the endpoint edge is the Wild West. It really is. Certainly for military, you've got mil standards. For automotive, you've got automotive standards. For ag, I don't know. For the example you brought, I don't know. We need to get smarter about this. But I think it's evolving. I think you see kind of these industry consortiums or I don't know, bodies, forming. Like again, I'll mention Open 19 to set maybe not standards, but kind of reference architectures. But yeah, good question. I know that was somewhat of a roundabout answer.
Well, it's a foggy fact,
yes,
in a lot of ways, right?
Yeah, absolutely. Okay, so kind of building from that, and maybe kind of looking at storage from maybe a hardware taxonomy or hardware segmentation view. This is how Solidigm kind of looks at kind of, again, a hardware taxonomy based view of the storage opportunities. And I'll walk through this really quick. And there's links to good examples here, but everybody knows what a training server is. Everyone knows what an inference server is. Certainly you can see those in the core, but again, overall, we see a lot of inference moving rapidly to the edge. Then at the core, and we see this mostly in enterprise, you can kind of, we see the emergence of kind of storage pipelines that could not only feed a training and inference server, but can feed a big data analytics, enterprise resource planning, data, business intelligence type of usages. And so that's kind of what's going on in the core. Edge infrastructure, we see, again, simple model, but maybe kind of two segments there. One is an on-prem server. So this could be the main server on a factory floor. And then you're going to have smaller servers around that smart factory floor. And so those, because they're in a controlled environment, they're not maybe as subject to these ambient conditions that we've been talking about. And then in edge infrastructure, we also see, there is ruggedized servers. And maybe, at least from our perspective, the most prominent example there is AWS Snowball Edge, which I believe has about 80 terabytes of storage. But that's a really good example of a ruggedized kind of edge infrastructure service, which, as long as I'm talking about the AWS Snow family, that then is paired with a Snow Cone in terms of an endpoint server. And literally, it's cool. You can go on YouTube and find videos of these devices being attached to a drone. And doing AI from the sky. In space, there's videos of AWS Snow Cone out in space. So that's kind of edge infrastructure. Endpoint, you see kind of complementary examples. We see kind of on-prem or sealed servers, ruggedized servers, and then obviously you've got what everybody's aware of as your ruggedized on-device. Everyone literally has a ruggedized on-device AI in their pocket now, right? In terms of their phone. Security cameras, vehicles, robotics, et cetera. So this is kind of from a storage taxonomy perspective, how we're looking at this opportunity. Okay. And I think, okay, one more slide here. And to me, it's, I think, going to talk about this, so I won't spend a lot of time here. When at a macro level, I talked about all the data increasingly moving to the edge, driven by one of the big factors, AI. I think when you look at from a storage workload perspective, we think it's increasingly becoming kind of a read dominant world where you've got things like AI and big data analytics and content delivery networks, which just get better, smarter, more immersive with storing and accessing and analyzing more and more data. And what we're sharing with you is a NetApp study done over, I think, a couple million drives over, or no, was it 2 million drives? Yeah, 2 million drives. Which basically concluded that the vast majority of drives are in a kind of supporting a read dominant or a read intensive workload.
Is that going to change? Is that going to change the direction of work you're doing? And I'm thinking I do a lot of work with data acquisition. So there's people that I've seen people that were limited before, not by how fast the drive could work, by how much RAM they had. Because first we were dumping everything into a temporary drive and then pushing it to RAM later. I watched some telescope people just excited because in the early 2000s somebody said, "Oh yeah, we've got a gig of memory," and they said, "Oh cool, we can run for 3/4 of a second. That's awesome."
Good question. I think I think it's going to reinforce what we do. And by that, I mean, we and Janice will share some details with you. You saw us, we launched a 61.44 terabyte drive. And that is because we see where the industry is going in terms of, some of these workloads that we talked about, in terms of just, the growth of data is not slowing down. We looked at, we talked about the sensor growth in just, a car example. We talked about a smart agriculture example. So, the need to efficiently store and access at speed vast amounts of data at the edge, we think is where the industry is going. And we think that with our QLC portfolio and our continued investment, boy, I'm really sounding like a commercial here, and our continued investment in leading the industry in storage density is where the industry is going.